Hello everyone, welcome back to my channel. Let's solve today's Leetcode problem 3347, maximum frequency of an element after performing operations. Okay, you are given an integer array nums and two integers k and num operations. You must perform num operation times on nums, where in each operation you select an index I that was not selected in the previous operation and an integer in the range of minus k to k to nums of 5. We have to add an integer which is in this range to nums of 5. Return the maximum possible frequency of an element in nums after performing the operation. This problem is exactly same as yesterday's problem, whereas the only difference is in its constraints. Okay, so length is in the range of 10 power 5 and each element is in the range of 1 to 10 power 5, whereas today it is in the range of 1 to 10 power 9. Okay, so in the yesterday's algorithm, what we have done is we have selected the minimum and the maximum element of the input array, and then we are checking whether I can convert all the numbers to one of these numbers in this range and identifying the operations required for it to convert to the particular number, and also checking after performing those operations, okay, how many of them, what is the count basically. Okay, so here let's say we want to convert all the elements to nums. So what would be, if I want to convert all the elements to nums, then I will actually check how many of my elements in the array can be converted into num and what is the operations required to convert. Okay, and we will actually take the minimum operations required, and we'll only perform those many operations and check how many elements we can actually make equal to nums. Okay, so there we have what we have done is we have assumed that we want to convert all the elements to a particular number, and then let's say we want to convert all the elements to nums, and then we are identifying what are the potential candidates which can be converted to num, right? Because we have a restriction that we can only add in the range of minus k to k, so there will be only few specific numbers which can be converted to num. Once we have identified a specific range which we can convert, if the range contains more number of elements than the number of operations we have, then we'll only convert the elements which are equal, only the elements which are actually equal to the number of operations. Let's say 5 elements we have in the range and we only 3 operations to do, so only three numbers will be converted into the desired number, right? And there is also one thing which we are also looking is, while we are doing the conversion, okay, if the particular number already exists in the given array, that means I don't have to perform an operation, right? So this case was handled either by taking the minimum of right minus left plus 1 or the number of operations because plus the frequency of that particular number, because it was already present in the given array, so I don't have to again convert it. Okay, so either you can subtract it over here or you can add it over here. Okay, so this approach actually takes because for each element we are trying to identify the both left and right elements, so this is taking a time complexity of the range times the log n, right? So how can we optimize it? So do I really have to check for each and every element in this range is the question now. Okay, so how can we answer this question? Okay, let's say I have only 2 elements in my array. Okay, and these are the possible ranges range of elements. Okay, so let's say this is 5, so and k is equal to 2. Let's say n is equal to 2, the number is equal to 2, and k is equal to 1, then this will be minus 1 and this will be plus 1, right? So only these elements are the potential candidates which can be converted into this number. Similarly, I have one more number over here, and considering some k value which was considered previously, this is the potential range of elements which can be actually converted to here, this particular number. Okay, so these are the 3 possible cases which can be occurred for any 2 numbers, right? Either the ranges can be overlapping, or both the end ranges can be the same value, or there will not be any overlapping at all. Okay, so if you see, if I choose to convert both the numbers to this particular value, okay, so this can be converted into this value because this is number actually falls in its range. So this will actually, we can perform it in one operation. So either you choose this, any value in this particular range will always require one operation to convert. Okay, if I want to convert exactly equal to nums, okay, exactly equal to this particular value, I don't have to perform any action. Okay, so if you see here, I have to perform one action, here I have to perform zero action. Okay, again if you choose, if I have to convert to this particular number which is end of this, then I have to I can convert this into this and also convert this number into this. So I require two operations to convert into this value. Okay, so if you see, the answer over here is 1, the answer over exactly this value is 0, the answer over here is 2, the answer over here is 0, and answer over here would be 1. Okay, so if you see, only at the edge, only at the uh, only at the edges of those lines, or exactly on this particular mid value, which is actually the number which was present in the given array, there the answer is actually changing. In rest all other cases, the answer is actually remaining the same, right? So taking this observation into consideration, all we have to do is to check whether I can convert all the numbers, identify the numbers which can be converted into this particular edge value, or convert into this particular edge value, or this edge value, or this edge value, and so on and so forth. So for any given number, okay, all I have to do, for let's say I have nums of 5, all I have to do is to check whether nums of I minus k, nums of I plus k, what is the operations required, I mean the total number of elements which can be converted into these numbers, okay, with a given constraint, with a given number of operations. Okay, so I will just repeat it once again. All we will do is basically check for these three values. Okay, we will identify the elements in the given array which can be converted into these three values for each and every element. Okay, and once we have done the conversion, we'll basically take the maximum for all those things. So how can I, in previous algorithm we already identified what will be, this will give you the number of elements which can be converted, right? But here what we are doing, we are checking for each and every possible value. Instead of checking each and every possible value, I have to check the number of elements, the maximum elements which can be converted into this and this value. Okay, I will show you how I implemented this algorithm. Okay, first I am sorting all the elements. So this sorting will actually help us to identify the left bound as well as right bound. So this sorting is actually helping us over there. Okay, this is required. And the frequency, as you can see here, we are, while calculating the number of elements which can be converted, we are also considering the frequency. Okay, so we want to convert we want to identify the frequencies, and we also need a sorted form of all the elements. Okay, like nums for each element, we are actually identifying num minus k, num and num plus k, and then storing it in the nodes in the sorted form. Okay, which is in the tree set, I am storing it in a sorted form. Okay, yeah. So once I got all the elements in the sorted form of this particular combination, right, I will basically, for each element I will be finding its left bound and the right bound for node minus k and node plus k. So this will give me the range of elements which are potentially eligible to convert. Once I identified the potential range, and then I will calculate the elements which are actually converted, and then I will update my answer. Okay, so let's try to submit this algorithm. As you can see, it has satisfied all the test cases and it is pretty efficient. Yeah, so here we are not actually considering each and every possible elements in the range. We are only taking the values for each num in the given array. We are taking 3 different values. So it is actually, this loop will actually run for 3 times the number of elements, and we are applying binary search, which will be log of n. So this would be the overall time complexity big O of this, which will be eventually n log n itself. Yeah, that's all about this problem statement. And in terms of space complexity, this would actually take out big O of 3 times n, which is actually big O of n. and space complexity in the worst case it will take up to big of n, and the sorting will take a time complexity of n log n. So the worst time complexity will be, the overall time complexity will be basically this time complexity taken for this particular code to execute. So sorry. Yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. I will be posting on daily basis. Thank you.